See here, we have what is a solenoid? It is a long helical wire. Okay, long. There is a hollow circular ring, or long. It's a long helical wire whose length is much greater than the radius. Second is they are closely spaced, and enabled wires are used for winding. Okay, so they are very closely spaced. Here, what happens here? L is the length of the coil, R is the radius. So B into L is equal to what? Mu 0 into I. Here we are writing N is equal to number density, number of turns per unit length. So B into L is equal to mu 0 into IN. So here L and L will go away. N is what? Number of turns per unit length. L and N will go away. B is equal to mu 0 Ni. That's a formula. Okay. Now, so we'll go with toroid now. Is it clear? Solenoid formula is this one. Small n is number of turns per unit length. Okay, keep that in the mind. Now, it's not number of turns. So next one is what? Toroid. What is a toroid here? Okay, so next one is what here? The toroid. Okay. So in toroid, what happens here? Like here, this is a toroid means like it's like a, have you seen a polo ring or a donut? It's like a donut.
Yes, sir.
So what happens here? The wire is in the form of like this. So this is the current. Okay, the current is entering and the current is leaving. So one side the current is entering, the other side the current is leaving. Now, so there are 3 points we have taken here. One is P and one is Q. Point P, point Q, and point Q, and then one is at the center. Okay. So here we have 3 points. See carefully, we have 3 points. The current is current is coming out. Cross means current is coming out. Dot means current is going in. Dot means current is coming out. Cross means current is going in. Okay. The wire is in that way, if you take like that. Now there is a magnetic field here. Here, the magnetic field at point P will be 0. Here also the point P is 0. Why? The magnetic field due to the magnetic field here is what? Clockwise. And here it will be, suppose if the current is going in, this is clockwise, and here it is anti-clockwise. That will cancel out. Here also, clockwise and anti-clockwise, it will cancel out. Only magnetic field is here. The magnetic field is at the center of the circle. Clear? Is that clear? So the magnetic field is not only at the center of the circle. Clear with you? So what is the magnetic field here? We are not going to solve all the whole formula now. The same formula here. It is also equal to what? Mu 0. B is equal to what? The formula is B is equal to B into L is equal to mu 0 Ni. B into L is equal to mu 0 Ni. Okay. What is L here again? L is, this is also circle. The circle, this is also circle. Okay. So this is 2 pi r, which is equal to mu 0 into N is number of turns per unit length. What is that? That is also again L is again here. N is equal to small n into cap L. So L is again 2 pi r. Okay. So what will happen now? B into 2 pi r is equal to mu 0 into L right here. 2 pi r into n into I. So this and this will go away. What is the formula? B is equal to mu 0 Ni. This is the formula for magnetic field. Okay. Is that clear? So one is about the current carrying wire, one is about the solenoid, one is about the toroid. All the 3 are important. Okay. And in the previous case, we studied about the wire loop. Okay, in Biot-Savart law. So there are total 4 cases, 3 here and one there. One we can make it 2 in that again. One is at the center, one is not at the center. Clear with you all? Suppose here, if thumb is the direction of the current, curled finger will show the direction of the magnetic field. Now, see, for a toroid means what? Toroid means like it's a polo ring and the current is wrapped, the wire is wrapped over it. So what happens here? If you see carefully here, what is happening? This point and this point. Here the wire is coming out. The wire is coming out means it is dot and this is cross. So cross and dot means if the current is going in, this is clockwise. Magnetic field is clockwise. Here it is anti-clockwise. Clockwise, anti-clockwise. So because of that, magnetic field here at this point will be 0. Here also it will be 0. Only magnetic field is at this point. Here, how much is that? BL is equal to mu 0 Ni. L is again, both are circles. This is also a circle. The wires are also circular loops. Okay. So here we have L is equal to 2 pi r mu 0 N. What is N? Small n into L. But what is again L? L is 2 pi r N. So just you have used this formula, substitute here, and then we get same formula. So the formula for solenoid and toroid is same. Okay. Is it clear?
Yes, sir.
Okay. Please copy this.